Okay, so this is lesson 1 of the Powers and Exponents unit in Math 9, and I'm going to start with an application question, something to introduce this topic. We're going to look at some bacteria growth. It's a really simple video, but it's one of my favorites showing bacteria growth and just how fast it happens. So when bacteria grows, about every 20 minutes for certain bacteria, essentially each cell just divides in half and it grows really fast. It grows exponentially. So we're going to look at the pattern of how this bacteria grows and how that looks mathematically. Okay, so let's close that video and fill out this table here. So bacteria population with enough space and nutrients will double in size every 20 minutes. So we're going to fill out the table and then try and understand this pattern. Lots of things in real life grow this way too, so there's lots of other applications that we'll see in this unit as well. Okay, so initially we started with just one bacteria, so we're going to leave that blank for now. Then it's going to double, so it's going to cut in half. So basically 1 will turn into 2, and so we'll just have 2 bacteria, and that is essentially 2 to the power of 1. After 40 minutes, that 2 bacteria will double to 4. I'm not going to draw out every single one, but and so that essentially we've just doubled it, and so we write that as 2 to the power of 2. Now let's keep going. We have 8 bacteria, then 16, then 32, then double again, 64, then double again, 128. Then after 3 hours, 180 minutes, we'll have 256 bacteria. Now I can't draw all of those out, but we can represent those numbers in different ways. So essentially every single time we're doubling, we're multiplying by another 2. So for 32, we'd have 5 2's. I'm running out of space here, so I'll move over. And then for 64, I'll have 6 2's. And then for 128, I'll have 7 2's. And you'll notice that it gets a little tedious to write out all these 2's every time. So we've come up with a notation that is a lot easier and faster, more efficient to use when you are having this repeated sort of multiplication. So what we do is we write the base, which is what we're multiplying by, so in this case 2, and then however many times we multiply it, that's what we write as the exponent. So 2 times 2 times 2 would be 2 to the power of 3. Then multiply by 2 again, it's 2 to the power of 4, then 2 to the power of 5, 2 to the power of 6. See, it's much more efficient to write it that way. So why do we use exponential form? It's efficient, especially with higher powers of 2. It takes a really long time to write that out. Okay, let's go to this little image here, which is just showing the different names for all the terms. So this entire thing is called a power. What you're multiplying by is the base. So in this case, 2 times 2 times 2 times 2. And the little number here is the exponent. That's how many times you're multiplying by. So this one would be 1, 2, 3, 4 times. Okay, let's practice writing out some powers in different formats. So here we have some exponential forms. You could pause the video here and try these on your own if you want, or you can do them along with me. 5 to the power of 3. So as repeated multiplication, what that means is we're going to multiply by 5, that's the base, 3 times. That's the exponent. So it's going to be 5 times 5 times 5. 5 times 5 is 25. Multiplied by another 5 would be 125. Okay, this one here, negative numbers. Important to understand how those work as well. So this time our base is negative 10, and we're multiplying that 7 times. So it's going to be negative 10 times negative 10 times negative 10. You can speed up the video here if you want. Takes a while to write it all out. 1, 2, 3, 4, 5, 6, 7. Now when we multiply an odd number of negative numbers, the answer is going to be negative. If we had an even number of negative numbers, it would be positive because all the negatives cancel out. And multiplying by a bunch of 10s, you essentially just count up the zeros. So 1, 2, 3, 4, 5, 6, 7 zeros. Okay, next one. Our base is -6. Our exponent is 2. That means we're multiplying by -6 twice. So that makes positive 36. Here the negative signs canceled out because we had an even number of them. Okay, let's go from the repeated multiplication. So here we are multiplying by 3 4 times. So it'd be 3 to the power of 4. And if I was going to answer that, it'd be 3 times 3, which is 9, times another 3, which is 27, times another 3, which is 81. Okay, now with fractions, it works the same way. Our base is still going to be this number here. So I'm multiplying by -7/2 5 times. So it's going to be -7/2 to the power of 5. And when you multiply the numbers, you just multiply the numerators and the denominators like you would normally multiply fractions. So the answer is going to be negative since there's an odd number of them. And 7 times 7 times 7 times 7 times 7 is a big number. It's 16,807. And 2 times 2 times 2 times 2 times 2 is 32. All right. This one here, we're going from the number. Now, since it's just 1 with a bunch of zeros, I know it's a power of 10, and I can count up those zeros. 1, 2, 3, 4, 5, 6. So it's going to be 10 times 10 times 10 times 10 times 10 times 10, which is 10 to the power of 6. Bonus question, can you write this in another way? Give you a second to think about that. Could you write that same number as a different power? So an example would be, you could make it 100 times 100 times 100. So it could be 100 to the power of 3. Another way you could do it would be 1,000 times 1,000. That would still give 6 zeros. So sometimes you can write a number, or different powers will have the same result. Okay, so there are a few options there. Okay, I'm just realizing something right now. I'm going to go back to the original table. I forgot to fill out this first number. So notice the pattern here in the powers from our exponents. We haven't talked about powers of 0 yet. So if we follow the pattern, then this would be the power of 0, and that's equal to 1. So that's another rule you need to know, that anything to the power of 0 equals 1. So not just 2, but any number to the power of 0 would equal 1. Just wanted to add that in. Okay, example 2. What is the difference between -3 to the power of 4 and -3 to the power of 4? One with brackets, one without. So when there are brackets, what that means is this power of 4 applies to everything inside that bracket. So when we write this out with repeated multiplication, we get -3 times -3 times -3 times -3. And because there's an even number of negative signs, the answer is going to be positive 81. Now here, when you have -3 to the power of 4 with no bracket, the negative sign is not part of the base. So the power of 4 is just the power on whatever it's right next to if there's no brackets. You can assume that. So there's actually only one negative sign, and then it's just 3 times 3 times 3 times 3. So this answer would be -81. So those are different, and it is important to understand the difference. Example 3. It's going to remind you that that is 1. Any power of 0 is 1. And you can go ahead and watch this video if you want to. And that's the end of the lesson.